they're negative angles, and it's a little confusing. I guess I can show you one more of these type. And go ahead and graph y equals sine x one more time, without looking at your other one. I want to give you a little bit of time to work on this. I actually need one more in this direction. If you can, graph it a little longer than normal over here, because I want to get some negatives in there. I should run it closer to the middle. In fact, I think I will. Retry. I'm going to drive the middle this time. All right. Did everybody graph y equals sine x? All right, check this out, and this is an important idea. Here's my graph of sine x. And I am going to do something to this that's very strange. I am going to change the sign of all of my x's. This is different than negative sine of x. Let me show you how it's different. If I do y equals negative sine x, then I'm changing the sign of all the y's, and it flips across the x-axis. You understand if I stick a negative out in front of this thing, that it changes the y values? It takes all these positive y values and makes them negative and reflects this down here. And takes this one and reflects it up here. Got that? This does not do that. This takes these and puts them over here and takes these and puts them over here. It's a reflection across the y-axis. Now what's really weird is that you get the same thing either way. But you're doing something else. Does everybody see the difference? This is taking this and putting it over here, and taking this and putting it over here, because you're changing the signs of the x's. So it looks like this. I'm taking this and reflecting it over here. Whoops, sorry. Reflecting it over here. And this, I'm reflecting over here. Isn't that the same as doing this? Got it? This is the same as this. Now what's interesting about cosine is that when you reflect it across the x-axis, you get the exact same thing. The cosine of negative x is the same as the cosine of x. Can you see why? Show it to you. Here's cosine. And I'll start here. There's cosine, huh? Take this and put it over here. Take this and put it over here. Don't you get the same thing? They're the same. Now that will lead you to be able to find what the tangent of negative x is. The tangent of negative x, and I'll give you a hint, isn't that the sine of negative x over the cosine of negative x? Well, wait a minute. Isn't this the negative sine x? And isn't this the same as positive cosine x? And what is this? Take the negative x. They're reflecting this way. Aren't these the same? Now that was a really good question. And I'd like to go over the graph of it. It's a great question. Did you hear what you asked? You asked, why is this the same as this? Watch. I'll show you just really quick. It's not hard. Draw an angle like this. Isn't the cosine the adjacent over the hypotenuse? Here's the angle, yeah? Like alpha? Now take a negative angle alpha. Isn't this adjacent side still positive over the hypotenuse? A smart trig class knows that all of them are positive in the first quadrant and cosine is positive in the fourth quadrant, excuse me. See that? Aren't they equal? Here's alpha, here's negative alpha. Now look what happens in this quadrant. Here's another angle, theta. Here's another angle, negative theta. Aren't the cosines the same? They're both negative adjacent over hypotenuse. See how I have a negative adjacent this time? A lot there. A lot of stuff. That's why. Now for sine, this one's positive, that one's negative, this one's negative, and this one's positive. Yeah? Okay. Let's think about it. Try them. Do stuff. Just try stuff. But all I can tell you is play with them and have a little fun with it. If you get a big mess, that's okay. Try something else. Because you never know what you're going to get out of these. It's the fun in it.